I should clarify something. In my last video, I said that correlation and regression was simple, but that's not what I meant. What I meant was that I'm only going to do very simple cases of correlation and regression. Regression is kind of the bread and butter of modern psychology. Even ANOVA is based on regression. You'll see that this table that we get is pretty similar to what we get when we run a regression as well. But before we get too much ahead of ourselves, let's go into correlation. So a correlation at its core is a look at linear associations between two variables, between two variables, but you can do it as many as you want. So the command to do it in R is COR. I'm going to grab my data set, empty cars. I'm going to grab a subset of data set, all my rows, and go miles per gallon, cylinders, displacement. And I'm going to say use equals complete. So that's this handles my missing data for the correlation, and I'm treating my cylinders here kind of like a continuous variable. As we've seen, there is a continuous nature of them, so I'm treating them like that. But you need to be sure that with a correlation matrix, you can only put in continuous variables or binary dichotomous variables. So they're either like a 0 or a 1, and the interpretation of them will be slightly different, but let me show you this. So empty cars, miles per gallon with cylinders. There's the correlation coefficient is -0.85, and my displacement is -0.85 again. And then I've got cylinders with displacement is 0.9, and if you notice, we've got ones coming down the diagonal, and then it's symmetric around the diagonal. That's nice, but unfortunately it doesn't tell you if those correlations are significant or not, just what the correlation coefficient is. That's one thing that I don't like about R. You can do core test and say empty cars, MPG, and empty cars at CYL. Use equals pairwise dot complete observations. That's just to tell it how to handle the missing data. So it gives me this again, which is almost the same as that. I think we estimated, nope, it is the same. If it had been different, it would have just been because we were estimating missing data slightly differently. Here's the p-value, so it's definitely less than 0.001. This is a very significant correlation, but you can only do it one at a time. So that's something that I really don't like about R. But on the flip side, you also have, because R is open source, there are plenty of options available for people to come up with things by themselves. So I've included in your folder something that's called Corestars.r. So this is a user-defined function, so somebody came up with it, and they decided that they wanted to be able to do what I'm about to show you. So when we want to use it, we have to say source. It's kind of like the library command, except we're using something that's on our computer instead. Corestars.r, because that's what this is called right there. Run it, and it says, okay, I recognize that. And then use Corestars. And I'm going to grab this here. Put that in so I don't have to type as much. So now, instead of giving me, it simplifies them down to just 2 digits of precision and gives me some p-values here. I mean, it doesn't give me p-values. It gives me how many stars they are, which is really useful for knowing how to move forward. It's pretty great, I think. Sometimes you may miss having the exact p-values, and you'll have to look exactly at the documentation, I guess. All the normal ones, like we have 1, 2, and 3 stars that are less than 0.05, less than 0.01, less than 0.001, but this 4 stars is just to be really, really good. It's 0.0001, so there's an extra 0 there. So that's pretty useful, but if you were to report this in an APA manuscript, it would just be 3 stars. But he just wanted to show you, when he designed it, how awesome it could be. Now, a linear regression, at its core, is the same as a correlation, except you can control for things. So again, t-test is like an ANOVA, except an ANOVA you can control for things. A linear regression is like a correlation, except you can control for things. In fact, if you do a linear regression just with a main dependent and independent variable, you'll get the correlation coefficient, the standardized correlation coefficient, but that's somewhere else. But yeah, so like the ANOVA, you have to do this in 2 steps too. So I'll say M2, that's my name that I came up with. You could call it whatever you want. I'm going to do linear model, LM, do my main dependent variable, my outcome variable, and then my main independent variable plus a control that I want. Data equals MT cars. It defined it. It showed up here. Now I go summary of M2, and it gives me all of this. So it tells you some stuff about your residuals. Here are the coefficients that you need. So that's an unstandardized coefficient, and it tells you what the significance level of it is. And there's your p-value. So cylinders, the number of cylinders predicts your miles per gallon, with lower cylinders being associated with higher miles per gallon, and that's significant with a 0.03 p-value, and there's your significance codes there. There's your F statistic if you want to report it. There's your R squared, so that's probably a better R squared than you would get. This is saying that 76% of the variance, or how much MPG changes, can be explained just by what's included in our model, which is basically just cylinders and a tiny little bit of displacement, though that's not significant, so it's hard to say. And plus that coefficient is a lot more small. I won't go much into the interpretation of regression because I assume that you have some basic knowledge of regression by the time you take this and are learning R. Okay, so it's also very useful to show a linear regression plot. It helps to visualize it. So I'm just going to say M3 and say linear model, but in order to do this, you have to create it just bivariate, so 2 variables. So we'll just say MPG, and for this one, I'll do cylinders, data equals MT cars, summary of M3. So again, we're still seeing a similar p-value, but without controlling for displacement, this coefficient has changed. So has that, but overall, the interpretation hasn't really changed that much. Let's grab some of the coefficients by doing cars coef, C-O-E-F. Grab the coefficients of M3. Now you can see the coefficients here. Cars coef. So if you need to see them, there's our coefficients there, if you ever need to like export them or anything. But right now, oh, I guess that's why we saved them. I'll show you in a sec. Plot empty cars. You put your x variable first, so your predictor variable first, followed by your outcome variable, or your y, your dependent variable, whatever it is. You see this plot has now showed up, and then you say AB line cars coef, and this plots the regression line. Well, I think you might have to run them together. It works when you do it in a chunk, so I'll show you here. And it'll work as long as you run them together. It will work. Yeah, I'm not sure what happened there, but if you put both of them together and you run them, it brings up this. So we saved the coefficients so that it could create the regression line, and there's the data that we're seeing, if that makes sense. To be able to do some interaction plots, I'll show you using this here. I'll just do it. So you have to install some packages. So pause this video and install those packages by clicking here. You have to grab some libraries, and I'll just run that here so that I can show you the plots. It looks like they all disappeared, which is unfortunate. But an interaction plot could be made doing this. With interaction, you have to define something as a categorical variable and then put it into your model. Again, we do an LM model, and then you can use this plot model, which is included in those packages, to create some things. So I would recommend playing around with this when you're ready to do interactions. It's a little more complicated, so I'm not going to go through it in depth, but when you're ready to do interactions, come look through this syntax here, and you should be able to figure out exactly what you need to run it. And here's some more regression plots that you could have. There's just the normal plot, and then here are, you split graphs by transmission style, which is AM. So you do MPG and then tilde displacement, which is the exact same thing as this, but then you put the bar, which is shift, and then the key above enter, that one. AM, which is automatic transmission versus manual transmission. You create some panel smooth data cars. That allows you to split your regression based on another variable. It's a very simple moderation. It's not technically a test of moderation, but you can do it. And that should cover it for regression. So that ends the tutorials that I have on basic statistics, and I hope that you're successful. And if you have any questions, come talk to us at the Family Home and Research Support Center. Our lab hours, by the time you watch this, may be different, but if you come here and look at our lab hours, there should be someone in there who can help you with R or whatever language you would like help with. So thank you very much, and I'll talk to you later.